This Kia truck has been swallowed by the jungle, left to rot under vines and banana leaves for years. Today, one craftsman begins the grueling process of digging it out. The goal isn't just recovery, it's a complete mechanical resurrection. After inspecting the severely degraded undercarriage, the first logistical hurdle is mobilization. A proper recovery operation requires hauling gear, and this old motorcycle will serve as a nimble scout vehicle. Loading it onto the rusted flatbed without a proper ramp relies on a makeshift wooden incline and raw friction. The angle of the plank must be shallow enough to prevent the bike from bottoming out, yet steep enough to fit the clearance. Getting the bike secured is just preparation. The real challenge lies in the truck's seized drivetrain. Momentum is the only way out of deep mire. With the front wheels bogged down in thick clay, traction is entirely non-existent. The mud acts like a physical vacuum, sealing around the tires and creating immense suction against the rubber. Overcoming this requires synchronized pushing from the exterior while the driver carefully feathers the throttle. Too much power, and the tires simply dig a deeper rut, high-centering the chassis. The manual effort is brutal, but inch by inch, the suction finally breaks. Clear of the mud, the mechanical triage begins at the wheels. Decades of trapped moisture have fused the brake drum assembly into a solid mass of oxidized iron. The internal returns, springs, and retaining pins are highly brittle, requiring careful extraction with pliers to avoid snapping the tension hooks. Applying a thick layer of grease directly to the hub bearings prevents total seizure. This immediate lubrication is crucial, allowing the heavy chassis to finally roll forward into the workspace. With the chassis back on solid ground, the teardown escalates. Accessing the drivetrain requires removing the heavy steel flatbed entirely. The side panels are detached, first to reduce overall weight, and prevent bending the frame during the lift. Using a manual yellow chain hoist allows for precise load control. The straps must be positioned at the bed's exact center of gravity. An unbalanced lift could send hundreds of pounds of rusty metal swinging dangerously. As the hoist takes the tension, the rusted mounting bolts give way. Removing the bed exposes the full extent of the truck's decay. The bare chassis reveals decades of neglected maintenance, compromised structural brackets, and a severely corroded driveline. Everything from this point downward will need to be systematically unbolted, cut, or extracted. Some components are far too fused for standard hand tools to break loose. When rust chemically welds steel brackets directly to the frame, an oxyacetylene torch becomes the only viable option. The intense, focused flame easily slices through the oxidized metal, severing the deep molecular bonds of the iron oxide. Rapid heat expansion also helps break the stubborn grip of any surrounding seized bolts. It is a highly necessary, destructive step to liberate the underlying chassis for the restoration ahead. The fuel delivery system is a critical point of failure in forgotten vehicles. Old diesel degrades into a thick, corrosive sludge that rots tanks from the inside out. Before the tank can be dropped, penetrating oil is heavily applied to the mounting straps. This fluid seeps into the rusted threads, reducing the immense torque required to break them free. Even with lubrication, an impact wrench is necessary to shatter the rust's grip through rapid, percussive force. A wire brush clears the heavy surface flaking, revealing the structural integrity of the steel beneath. Freeing the tank clears the perimeter for the engine extraction. The teardown moves inward toward the transmission bell housing. The starter motor, heavy with internal copper windings and caked in external grime, is unbolted and pulled free. Its removal grants crucial access to the tight spaces between the block and the firewall. The mechanical linkages connecting the cab to the transmission are deeply oxidized. Turning these bolts entirely by hand is tedious, but it prevents snapping the brittle, aged steel shafts that power tools might easily shear off. After unbolting the transmission mounts, the focus shifts to the exhaust system, often the highest risk of the entire teardown. Exhaust manifold bolts endure extreme, repeated thermal cycling, expanding under intense heat and contracting rapidly as they cool. Over decades, this essentially bakes these steel threads directly into the cast iron block. Breaking them loose requires steady, immense leverage rather than sudden, violent shocks. A snapped stud deep inside the cylinder head would cost hours of precise drilling and tapping to repair. Constant, heavy pressure finally overcomes the thermal weld. With the bell housing bolts removed, the engine and transmission are ready to be divorced. However, the input shaft is often tightly bound to the clutch splines by rust and friction. A long steel pry bar provides the necessary mechanical advantage to wedge the massive cast iron housings apart. Once the initial seal is broken, the entire transmission assembly must be pulled straight backward along the chassis rails. The angle is critical. Dropping the heavy gearbox too soon could permanently bend the input shaft or damage the clutch plate. Sliding it cleanly away exposes the massive rear flywheel. This separation isolates the engine block, leaving it as the final, massive component anchored to the front of the frame. The path for extraction is now completely clear. Before the engine can be hoisted, every umbilical cord tethering it to the chassis must be severed. The original rubber coolant hoses and vacuum lines have long since lost their elasticity, hardening into rigid, brittle plastic over years of sun and thermal exposure. Loosening the rusty worm gear clamps is only half the battle. Pulling the thick primary coolant lines requires breaking the vulcanized bond formed between the old rubber and the aluminum water necks. The dark engine bay is systematically cleared of wiring harnesses and fuel returns, ensuring nothing snags when hundreds of pounds of iron finally swing upward. When pulling by hand fails, mechanical persuasion is required. A flathead screwdriver is carefully wedged under the lip of the stubbornly fused coolant hose. Prying breaks the vacuum seal and gently stretches the hardened rubber away from the metal flange. It requires a delicate touch. Gouging the soft aluminum neck of the engine block would create a permanent coolant leak later on. Working the tool around the perimeter eventually breaks the heavy bond. With the final stubborn lines peeled away, the grimy, neglected power plant is completely isolated and ready for the hoist. The extraction is a test of precise balance. A heavy-duty lifting strap is looped around the engine's upper structural points, finding the exact center of gravity. Using a manual chain hoist allows for micro-adjustments, lifting the massive iron block millimeters at a time. The tension slowly transfers from the corroded chassis, mounts to the steel chain. As it clears the frame rails, the sheer scale of the decay is fully visible. Caked in decades of sludge, soil, and leaked oil, the engine is finally free from the vehicle that entombed it. It is guided onto a cart, ready for the teardown to begin. Following an initial heavy pressure wash to reveal the bolt heads, the detailed teardown commences at the front accessory drive. The mechanical water pump is unbolted first. Its internal impeller is highly likely seized from pumping stagnant, rusty coolant for years. Removing the heavy front timing cover is next, which protects the engine's crucial internal synchronization gears. Using a power impact driver rapidly speeds up the extraction of dozens of perimeter bolts, though extreme care must be taken not to snap any weakened threads. Stripping away these aluminum front casings marks the transition into the engine's precision core. The top end of a diesel engine is a dense, complex network of high-pressure plumbing. Every steel fuel line must be carefully unscrewed from its specific fitting. Unlike standard low-pressure gasoline systems, diesel injection lines endure immense, rhythmic internal forces. The metal tubing is factory-shaped perfectly to match the injector angles. Bending or kinking one during removal would permanently ruin its precise flow dynamics. An impact driver easily removes the heavily rusted auxiliary brackets that anchor these lines to the block, which originally neutralized the severe vibrations that can crack rigid pipes. Loosening the delicate connections at the top of the fuel injectors requires a perfectly sized wrench to avoid rounding off the soft brass and steel locking nuts. Creating this clearance up top is absolutely mandatory. The tangled web of thin, oxidized metal lines must be entirely lifted away before the heavy valve cover can be breached safely. With the perimeter bolts safely removed, the valve cover is finally lifted, exposing the engine's mechanical valve train. The sight underneath is a grim testament to long-neglected maintenance. The rocker arms and heavy valve springs are suffocated under a thick, black blanket of coagulated oil and carbon sludge. When engine oil breaks down over extreme time and heat without being regularly changed, it turns into this highly abrasive, tar-like substance that rapidly wears down critical moving parts. The rocker arm assembly dictates the engine's precise breathing rhythm, physically opening and closing the valves thousands of times a minute. Removing the long, heavily oil-stained mounting studs frees the complex rocker shaft from the cylinder head. Piece by piece, the dark, sludge-soaked upper assembly is completely dismantled, revealing the bare tops of the valves buried below. The massive, rusted head bolts are extracted, breaking the final structural seal. Lifting the heavy cast iron cylinder head exposes the combustion chambers directly. The old head gasket has fused itself to the block's deck. A thin metal pick is meticulously used to scrape away the hardened, carbonized gasket material. The mating surface must be flawlessly smooth. Even a fraction of a millimeter of leftover debris could cause a catastrophic compression leak when the engine is eventually reassembled. Behind the front cover lies the engine's timing system, the intricate gear set that synchronizes the crankshaft's rotation with the camshaft's valve openings. Before the inner cover can even be unbolted, the deep accumulation of hardened grease and debris must be picked away just to locate the fasteners. The impact driver makes quick work of the perimeter bolts, revealing the massive steel timing gears inside. These gears are incredibly robust, utilizing direct meshing teeth rather than a rubber belt or chain, a hallmark of heavy-duty commercial diesel design. The thick black oil coating them proves they were at least lubricated before the engine died. Extracting the central locking bolt frees the primary gear, disconnecting the top end from the bottom block entirely. After dropping the clutch assembly and draining the remaining tar-like oil, the massive forged steel crankshaft is finally lifted clear of the main bearings. It is the heaviest single moving part in the engine, entirely responsible for translating the violent up and down motion of the pistons into smooth rotational force. With the heavy iron block entirely hollowed out, the focus immediately turns to the bare cylinder walls. The internal bores are meticulously inspected and cleaned, checking closely for deep vertical scoring or rust pitting that might indicate a catastrophic failure in the engine's forgotten past. Stripping the immense buildup of grease is absolutely mandatory before any precision restoration can safely begin. High-pressure water aggressively blasts away the thickest layers of surface grime from the heavy cast iron components, including the exhaust manifold and the raw block. The heavy crankshaft journals require special, focused attention, as accumulated sludge can easily block the microscopic oil passages drilled directly through the solid steel. Washing these disassembled parts on the open concrete floor allows the toxic, caked-on buildup of decades to finally drain away. The bare metal is fully exposed, revealing the true mechanical condition of the iron beneath. Back at the workbench, the cylinder head receives precise attention. Exhaust valves endure extreme heat and unburned fuel, leading to thick, rock-hard carbon deposits forming around the valve seats. This carbon buildup prevents the valves from closing flush, severely dropping engine compression and robbing power. Using a dedicated scraping tool, the technician carefully chisels away the hardened slag. The goal is to expose the bare, shiny steel of the seating ring without gouging the softer cast iron of the head itself. As the black residue flakes away, the clean metallic rim emerges, restoring the perfect geometry needed to trap high-pressure combustion. Water pressure removes the loose dirt, but only a heavy chemical solvent can dissolve the baked-on varnish and molecular-level oil stains. The cast iron block is suspended over a basin where stiff nylon brushes work the aggressive solvent deep into the porous metal casing and internal oil galleys. Every internal passage must be flush. A single flake of hardened sludge left behind could circulate into a fresh bearing and destroy the rebuilt engine on its first startup. The cylinder head receives the same meticulous chemical bath, submerging the intricate aluminum and iron castings, allows the solvent to break down grease hidden in the tight water jackets and intake runners. The dark, murky fluid in the bin is proof of the decades of internal contamination being drawn out. Finally, the delicate camshaft lobes and bearing journals are scrubbed clean. The transformation is striking. What was once a black, unrecognizable mass of grease is now bright, clean, factory-grade metal, entirely ready to accept fresh paint and new parts. The engine's true heart is its fuel delivery system, requiring an entirely separate, higher level of mechanical precision. A mechanical diesel injector operates under thousands of pounds of pressure, forcing raw fuel through microscopic pinholes to atomize it perfectly into the hot combustion chamber. Even a microscopic speck of rust or dirt can clog a nozzle, instantly causing a cylinder to severely misfire. Secured firmly in a heavy steel bench vise, the delicate injector nozzles are blasted directly with aerosolized solvent. The high-pressure chemical spray penetrates the intricate internal needle valves, flushing out any sticky residual diesel varnish left inside. Sealing high-pressure fuel lines leaves absolutely no margin for error. A thin strip of white Teflon tape is carefully wrapped around the threaded base of the injector nozzle. While not always factory spec, the tape acts as an additional thread sealant and anti-seize barrier, ensuring the high-compression fuel cannot weep past the steel threads. Assembling the two halves of the injector housing requires torque. Using two heavy wrenches simultaneously prevents the internal needle from twisting out of alignment while locking the outer casing down tight. With the injectors rebuilt and sealed, attention shifts to the heavy mechanical fuel pump. This complex, centralized unit is responsible for timing and distributing the massive hydraulic pressure to each individual cylinder. It is mounted firmly into the vise, ready to be cracked open and completely overhauled. Disassembling an inline diesel injection pump is remarkably akin to taking apart a large mechanical watch. Inside the heavy exterior housing lies a precise, synchronized sequence of camshafts, heavy return springs, and individual pumping plungers. These critical components must slide with absolutely zero friction to accurately meter the exact fuel delivery based on the driver's throttle input. As the pump is carefully dismantled, the tiny, intricate metal springs and highly polished plunger valves are extracted one by one. They are immediately dropped into a dedicated tray of clean solvent to soak. Any dry, aged diesel fuel on these microsurfaces creates a sticky lacquer that slows the plunger return rate, instantly throwing off the engine's timing. Wiping the main housing clean prepares the intricate unit for careful inspection and meticulous reassembly. After the intricate internal rebuild, the complex mechanical pump cannot simply be bolted directly back onto the engine. Its precise output must be definitively proven first. The freshly assembled unit is mounted directly to a specialized fuel injection calibration test bench. Rigid metal test lines are threaded tightly onto the pump's discharge ports, routing the high-pressure output straight up into a row of highly calibrated glass flow meters. Clean, specialized test fluid is poured into the system to act as an initial prime. When the bench's powerful electric motor spins the pump, perfectly simulating the running engine, the internal plungers rapidly fire. The test measures the exact volume of fuel delivered by each individual plunger across a set number of rotational strokes. If the fluid levels rising in the glass tubes do not match perfectly, the cylinders will fight each other, causing a rough, smoking idle. This machine ensures perfect mechanical harmony. With the internal flow rates perfectly balanced across all cylinders and the rigorous calibration complete, the pump is finally powered down. The high-pressure metal test lines are unthreaded and carefully set aside. Detaching the heavy, precisely tuned unit from the rigid test fixture requires a gentle, deliberate touch to avoid jarring any of the newly set internal adjustments. Lifting it safely back onto the main workbench marks the successful completion of the most delicate phase of the entire restoration process. The rebuilt engine now has a verified, perfectly calibrated mechanical heart, fully ready to reliably deliver thousands of pounds of instantaneous fuel pressure the moment the key is eventually turned. The final preparation of the complex fuel system involves strict, highly accurate dimensional checks. Using a precision metal caliper, the critical tolerances on the pump's external linkages are measured down to the exact fraction of a millimeter. Even a tiny, seemingly insignificant deviation in the external throttle arm linkage can drastically alter the engine's base idle speed or its maximum safe RPM limit. Every exposed component is wiped utterly spotless with a clean cloth before the final exterior covers are firmly secured. The fully restored mechanical pump now sits completely ready, forming a perfectly synchronized fuel delivery package. Bare, unsealed cast iron will inevitably begin to flash rust from ambient atmospheric humidity in a matter of hours. To permanently seal the freshly cleaned metal, a heavy, uniform coat of high-heat gray primer is thoroughly applied. Suspending the massive engine block from the air allows the atomized spray to penetrate deep into the complex casting ribs and tight exterior corners. The primer serves as a crucial microscopic anchor, etching directly into the porous iron to provide an unbreakable bonding layer for the final color coat. The heavy transition housing and the cylinder head receive the identical protective base layer, effectively sealing out the elements. The transformation from industrial salvage to a restored machine happens in the paint booth. A vibrant, high-gloss green enamel is laid over the primed block, a classic color choice that instantly highlights oil or coolant leaks for easy future diagnosis. The heavy engine enamel is chemically formulated to withstand extreme thermal expansion without cracking or peeling away. To create a striking visual contrast, the valve cover and the large mechanical cooling fan are coated in a brilliant, bright red. These rich, thick color coats do more than just make the engine look beautiful. They create a slick, impenetrable shell that repels oil, water, and future corrosion. With the heavy forged crankshaft already resting securely in its fresh lower bearings, the core rotating assembly begins to rapidly take shape. The brittle piston rings are carefully expanded by hand and slipped precisely over the aluminum crowns. These incredibly thin steel rings are what actually seal the immense explosive pressure of diesel combustion. The aluminum piston itself never truly touches the cast iron cylinder wall. Generous amounts of heavy, friction-reducing assembly lube are directly applied to the connecting rod bearings before the piston is carefully dropped down into the freshly honed green cylinder bore. From below the block, the connecting rod cap is precisely mated to the spinning crankshaft journal. An impact wrench quickly runs the heavy nuts up the threaded studs, securing the piston's powerful link to the main drive line. The mechanical heart of the block is finally coming together. Sliding a piston into a precise bore is impossible without the right specialty tool. A ratcheting ring compressor tightly squeezes the expanded steel rings flush against the piston skirt, allowing the entire assembly to slide cleanly down into the tight cast iron cylinder. Without this collar, the sharp rings would instantly catch on the block's deck edge and snap. Once seated, the critical step of final torque begins. A calibrated torque wrench is used to tighten the connecting rod bolts to a highly specific rotational force, ensuring the bearing shells are perfectly round and crush-free around the crankshaft. Sealing the engine from catastrophic oil loss starts at the rotating extremities. The bright red front cover plate is perfectly aligned over the protruding snout of the crankshaft. Because the shaft spins at thousands of revolutions per minute, a specialized rubber oil seal must be driven into the center of the housing. A hammer gently taps the circular seal perfectly flush. If it sits even slightly crooked, high-pressure oil will inevitably pour out the front of the running engine. A final, thin bead of liquid silicone sealant is applied precisely around the outer edge of the rubber lip. This guarantees an absolutely airtight, leak-proof barrier between the spinning steel and the stationary red aluminum casing. The bottom end is completely enclosed by the installation of the stamped steel oil pan. After applying a continuous unbroken bead of liquid gasket sealant around the block's perimeter, the deep black pan is carefully lowered into position. An impact driver rapidly secures the dozens of small perimeter bolts, crushing the silicone slightly to form a permanent, flexible seal that will hold quarts of hot oil safely inside. With the bottom end finally sealed shut, the wooden supports are removed and the block is rotated upright onto its heavy base. The bright red, freshly calibrated fuel injection pump is then bolted to the side of the green casing, linking the fuel system to the engine's core. The heartbeat of the engine relies on perfect mechanical synchronization. The massive, heavy steel timing gear is hoisted up and carefully aligned with the front shaft. This single gear bridges the rotational power from the crankshaft directly to the fuel pump and camshaft, dictating the exact millisecond fuel is injected and valves are open. Pushing it fully onto the keyed shaft ensures it cannot slip out of its strict alignment. A central locking bolt is torqued down, firmly clamping the heavy gear in place. To protect this critical moving assembly from debris and contain its lubricating oil splash, a smaller steel plate is bolted on, followed by the bright red outer front cover. A fresh circular seal is pressed into the very center, finalizing the front end enclosure. The exterior begins to fill out as the life support accessories are mounted to the block. The heavy black drive pulley slides onto the front shaft, locking into the keyway to eventually power the external belts. Next, the fresh water pump is bolted, flush against the side of the block, ready to push gallons of pressurized coolant through the internal water jackets to prevent meltdown. On the opposite side, the bright red oil filter housing is bolted into place. A brand new, pristine white oil filter is spun onto the threaded collar and tightened purely by hand. Using a wrench on a spin-on filter often overcrushes the internal rubber O-ring, practically guaranteeing a blowout under pressure. Power transfer to the road relies entirely on the heavy rear assembly. The massive steel flywheel is hoisted onto the rear crankshaft flange. Its sheer rotational mass is what keeps the engine spinning smoothly between individual cylinder combustions, preventing harsh, stalling vibrations. The bright red clutch pressure plate is then bolted directly over the friction disc. As the heavy impact driver locks the assembly down, the heavy springs inside the red casing compress, trapping the clutch disc tightly against the raw steel of the flywheel. This is the sole mechanical bridge between the engine's horsepower and the truck's wheels. With the bottom end completely sealed, attention moves outside to finalize the heavy top end. Resting securely on artificial grass to protect the freshly machined surfaces, the cylinder head is painstakingly assembled. Bare steel valves are dropped down into their perfectly cleaned guide ports. The incredibly stiff valve springs are placed over the protruding stems. Compressing these high-tension springs by hand requires serious leverage, exposing the tiny groove at the very top of the valve stem. Two microscopic, wedge-shaped metal keepers are carefully dropped into this groove when the downward pressure on the spring is suddenly released. The heavy upper retainer snaps upward, instantly locking the wedge keepers tightly against the valve stem. It is a brilliant, brutally simple mechanical friction lock that will easily hold the heavy valves together as they violently slam open and shut thousands of times every minute. The final securing bolts are torqued down, finalizing the dense, heavy cast iron cap of the engine. After torquing the head and setting the critical valve lash clearances, the lifeblood is finally reintroduced. Gallons of thick, fresh, heavy-duty oil are poured through a funnel, slowly cascading down through the valve train to fill the deep black pan below. The heavy cast iron exhaust manifold is bolted to the side of the block, utilizing a multi-layered steel gasket to withstand the extreme blazing heat of exiting diesel exhaust gases. Moving to the front of the green and red block, the technician uses a massive open-ended wrench to put the final heavy torque on the main housing bolts. Every structural fastener is double-checked before the final drive components are mounted. The final spinning accessories lock into place on the front of the block. The massive, bright red cooling fan is bolted directly to the water pump pulley, ensuring immense airflow over the engine block whenever it runs. A freshly painted green alternator is mounted to its heavy side bracket, ready to generate the electrical current required to sustain the vehicle. With the engine fully dressed, the massive green transmission bell housing is finally hoisted up and mated back to the rear of the block. The heavy impact driver runs the thick perimeter bolts down tight, permanently locking the heavy gearbox back against the clutch assembly. The complete driveline is now unified once again. An engine cannot breathe without its complex nervous system of fuel delivery. The technician carefully routes the rigid, high-pressure metal injection lines along the side of the green block. These thin steel pipes must be precisely bent and guided by hand to perfectly align the newly calibrated red pump to the top of the cylinder head. The fittings are locked down tightly with a wrench. Even a microscopic gap here would spray highly atomized diesel fuel everywhere under extreme hydraulic pressure. Across the top, clear plastic return lines are linked between the injectors to bleed off any excess unburned fuel back to a catch tray for the test run. Finally, the heavy steel fuel injectors are torqued firmly into the deep ports of the cylinder head, completing the high compression seal. The complex plumbing is completely finished. The engine is primed, fully sealed, and holding its breath. The moment of truth arrives on the bare workshop floor. A heavy battery cable is clamped directly to the starter motor, entirely bypassing the need for a chassis or an ignition key. A final visual check ensures the intricate fuel lines are fully primed. The electrical circuit is closed, and the heavy starter loudly engages the rear flywheel. For a split second, the engine cranks over, forcefully drawing raw fuel and compressed air into the dark cylinders. Then, the heavy block physically shudders as the diesel catches fire, roaring loudly to life. The massive red fan spins flawlessly, and the mechanical rhythm rapidly settles into a deafening, perfectly steady idle. What was a seized, rusted lump of scrap metal rotting in the jungle is a working machine again. Revived, highly capable, and honest about it. Every single hidden detail they cleaned and torqued is exactly what this immense reliability now rests on. Some things are undeniably worth the long, hard road back.